Right, so this is then the density required practical. Right, and what we're going to be doing in this, we're going to be investigating the density of 3 different types of objects: a regular shape, an irregular shape, and liquids. Right, we've got to be able to work out all 3, and each one of the kind of techniques is slightly different. Right, so what we're then going to be doing is we're going to be working out the density. Right, a bit of maths involved. Now, density is a little bit unusual, right, in the fact that if I was going to say time, time's in seconds. If I was going to say weight, weight's in newtons. If I was going to say mass, kilograms. But density, right, is one that kind of breaks those rules a little bit, and it depends a lot on the actual question that you're asked. So you could have kilograms per meter cubed, which is what's in the question. You could have kilograms per centimetre cubed. You could have grams per metre cubed, and you could have grams per centimetre cubed. And what you've got to do is you've got to look out for the question itself and what they're actually telling you to calculate it. Right, so this one we're going to look at is a regularly shaped object. All right, so what you're doing is you're just talking like a block. Okay, for each of your selected objects, measure the length, the width, and the height. Okay, so on here we've got length, width, height. Okay, and literally what you'll do then is if the length is 5 centimetres, the height is 2 centimetres, and the width is 3 centimetres, you literally multiply them together. So 5 times 2 is 10, times that is 30, and if it's in centimetres, it then becomes centimetre cubed. That is then working out the volume. What you then do is, you've got density equals, you've worked out the volume, it's 30, now you get the mass using a mass balance, and you just literally put it onto the mass balance. So here I've got centimetre cubed. I put it on my mass balance and it is 60 grams. So then what I do is, using my calculator, density equals 60 divided by 30 is 2. And because I've got grams and centimetre cubed, my units will be grams per centimetre cubed. Okay, dead straightforward. Then, calculating the density of a liquid. You're doing exactly the same kind of style thing, right, except there's one extra step. Measure the mass of the empty measuring cylinder. There's your measuring cylinder, right, and what you do is you put it onto the balance, and you can either record it down as 200 grams, or if you press the 0, it takes it back to 0 grams. Then you put your liquid in, right, there's your liquid in. And what you've got to do is you've got to know the difference between the two. So on this, it's then 250 grams, so it'd be 50 grams of liquid that's in there. If you'd done it on 0, then the actual scale on there would say 50 grams. All right. So 0 the mass balance, pour your solution into the measuring cylinder, calculate the mass, and then calculate the density. Now the problem then you've got the volume. So the volume is, you look at the scale, and to me that looks like 25 centimetre cubed. So density equals mass, 50 grams, divided by volume, 25, so I've got grams there, and I've got centimetre cubed there. 50 divided by 25 is 2, and because it's grams and centimetre cubed, grams per centimetre cubed. Okay, so that's the density of a liquid. The third one, right, I think it's probably the most interesting ones, is getting an irregular shaped object. So it could be anything, right? So it could be a pen, right? It could be a pen lid, right? It could be anything, right, that is a little bit harder to actually measure. Right, so what you do is you use this object here, which is called a displacement, or your Eureka can, right? And literally what you do is you fill it with water up to the spout. So you just pour it in until water starts coming out of the spout. Then you lower your object very carefully into the actual Eureka can, displacement can, and you then have a measuring cylinder underneath here, and any water that gets displaced, which is why it's called a displacement can, comes out and it fills this here. Okay, so that then is the water that has then been displaced. You then do the actual calculation. Density equals, you got the volume, I'm just going to make it up as 50 centimetre cubed, right? But then I've done something really stupid. What I've done is I've put the actual mass into my Eureka can, and I should have done something before. I should have measured the mass, right? So what I've done then is just re-putting it back again. I haven't put my mass in. My mass weighs 50 grams. Then you put it in, then you collect your 50 centimetre cubed of water. The density is 50 grams divided by 50 centimetre cubed, so it is 1 gram per centimetre cubed. Right, so that is then density, right? Now density, right, they could ask you any three of those methods. Probably the most likely one is the Eureka can one, because it's kind of a little bit more different, it's a little bit more interesting. You need to know the methods, but you definitely need to know the equation, right? Because if you don't know the equation, right, then you're never ever going to be able to answer any of the questions ever.
So now you've watched the required practicals. Now what you've got is your instructions about what you have to do. If you're unsure about anything to do with the video, then you need to go back through it. In the exercise books, don't write out the questions themselves. For shorter answers, just write out the answers that you're using in the question, Longer answers, do a plan, make sure you get the right order, and then bullet point or small, precise paragraphs. Don't do long reams of writing, it's not the way to do it. The questions are then on the next slide. Pause the video, and then when you've written the questions, review and see if it all makes sense.